NVIDIA's vision for the AI factory becomes clearer with Rubin CPX. Imagine a future where AI data centers operate like finely tuned factories, each component optimized for peak performance and cost efficiency. This is exactly the direction NVIDIA is heading with its latest announcement at the Infra AI Global Summit 2025. The company unveiled the Rubin CPX, a new addition to its Vera Rubin family of AI data center products. Unlike the standard Rubin AI Graphics Processing Unit, GPU, the Rubin CPX is designed to deliver high-value AI inference and content generation at a more affordable price point. But here's where it gets controversial. This new accelerator isn't just another GPU. It's a key piece in NVIDIA's broader strategy to build multi-GPU AI data centers that can handle diverse AI workloads seamlessly. Tirias Research, which has provided consulting services to NVIDIA and other AI industry players mentioned here, has long predicted the need for a variety of AI inference accelerators. Companies like AMD, Intel, and NVIDIA are all racing to develop specialized AI semiconductor solutions. The reality is that AI workloads are incredibly diverse. No two AI models are exactly alike. As AI adoption grows among consumers and enterprises, and as AI models evolve rapidly, there's a huge opportunity to tailor hardware specifically to different AI tasks or groups of models. However, despite this diversity, GPUs remain one of the most versatile and effective tools for both AI training and inference. NVIDIA's Rubin CPX announcement builds on this foundation in two important ways. Why GPUs still reign supreme in AI? First, consider the nature of the semiconductor industry itself. Technology trends often swing like a pendulum. When a new technology emerges, innovation happens at a breakneck pace, especially in AI, where new breakthroughs can occur daily. But as the technology matures, standards begin to form. At that stage, it makes sense to create dedicated chips, known as application-specific integrated circuits, ASICs, optimized for particular functions. Sometimes, these specialized functions eventually get integrated into general-purpose processors, like CPUs or GPUs. However, designing and manufacturing a custom chip can take 3 or more years, a lifetime in the fast-moving AI world. Since AI models and processing techniques are evolving so quickly, GPUs offer a more flexible and practical solution than ASICs for most AI applications today. Second, GPUs have a unique ability to be partitioned, allowing them to run multiple AI models simultaneously. There's a common misconception that the AI industry is on the verge of shifting entirely from training models to inference processing. But the truth is, inference workloads have already dominated AI processing for years. With the widespread deployment of models like OpenAI's ChatGPT, Google's Gemini, Microsoft's Copilot, DeepSeek's R and V series, Anthropic's Claude, and Perplexity AI, the majority of AI tasks today involve inference, using trained models to generate outputs. Thanks to their programmable nature and efficiency, AI GPUs power most generative and agentic AI workloads, making them the go-to choice for data centers worldwide. NVIDIA's expanding AI GPU ecosystem at GTC 2025, NVIDIA revealed several groundbreaking technologies aimed at constructing AI-focused data centers. These innovations include the NVL144 rack design, KV cache, Dynamo, enhanced NVLink, Spectrum X, and Quantum X networking technologies. KV cache is particularly interesting. It stores computed key and value tensors so they can be reused across AI generations and between GPUs, boosting efficiency. Dynamo is an open-source inference framework that orchestrates AI workloads within the data center, essentially acting as a traffic controller for AI tasks. The NVL144 RAT and NVIDIA's networking tech form the backbone infrastructure, while data center blueprints running on NVIDIA's Omniverse platform create a digital twin, a virtual replica, for designing, building, and operating these AI factories. Now with the Rubin CPX, NVIDIA takes another leap forward. This AI GPU inference accelerator is fine-tuned to excel at specific complex AI functions. NVIDIA describes the Rubin CPX as a context inference accelerator, capable of handling demanding tasks like processing millions of lines of software code, generating hours of video content, and supporting deep research applications. It works alongside the Vera CPU and Rubin AI GPU. The Vera CPU and Rubin GPU handle the heavy lifting of ingesting massive data volumes requiring intense computation, while the Rubin CPX takes over when it's time to generate output based on contextual inputs. This generation phase depends heavily on memory capacity and networking bandwidth. Though built on the same Rubin AI GPU architecture, the Rubin CPX is uniquely designed with 128 GB of GDDR7 memory and specialized hardware encode-decode engines to support video generation. It delivers an impressive 30 petaflops of performance using the NVFP4 data format, which is 3 times faster in attention acceleration compared to NVIDIA's previous GB300 NVL72 model. It can also process a context window of 1 million tokens, an enormous capacity for understanding and generating complex content. While these architectural changes reduce peak performance by about 20 petaflops compared to the standard Rubin AI GPU, they significantly boost efficiency in generating contextual tokens. NVIDIA's vision for integrated AI data center racks. Looking ahead, NVIDIA plans to offer the Rubin CPX integrated into a single rack alongside the Vera CPU and Rubin AI GPU, called the Vera Rubin NVL144 CPX. This rack will feature 36 Vera CPUs, 144 Rubin AI GPUs, and 144 Rubin CPXs equipped with 100 terabytes of high-speed memory and a staggering 1.7 petabytes per second of memory bandwidth. This setup achieves 8 exaflops of NVFP4 performance, a 7.5-fold increase over the GB300 NVL72 rack. NVIDIA estimates that a $100 million capital expenditure on this infrastructure could yield returns between $3 billion and $5 billion, representing an extraordinary 30 to 50 times return on investment. For those seeking even more flexibility, NVIDIA will also offer a dual-rack solution that pairs the Rubin CPX accelerator rack with the standard Vera Rubin NVL144 rack, adding an extra 50 terabytes of memory while maintaining the same performance level. What's next for AI GPU innovation? The Rubin CPX is just the beginning of NVIDIA's journey to create AI GPU accelerators tailored for high-end generative AI applications. It's likely we'll see future iterations of NVIDIA's AI GPU architectures targeting different segments of the AI market, such as smaller or more specialized AI models. There may even be multiple versions of the CPX platform, each optimized for distinct AI workloads. After all, AI is far from a one-size-fits-all technology. It encompasses a wide range of tasks that require different hardware optimizations. More importantly, NVIDIA's approach treats the entire data center as a unified system. By addressing potential bottlenecks across compute, memory, and networking, NVIDIA aims to maximize performance efficiency and deliver the best possible return on investment for AI infrastructure. A question that often arises is whether the AI industry needs new GPUs every year. Given the rapid pace of AI innovation, the answer is a resounding yes. To keep up with evolving AI models and workloads, the industry must continuously develop new, optimized GPUs tailored to the diverse demands of AI processing. So, what do you think? Is NVIDIA's multi-GPU AI factory vision the future of AI data centers? Or could specialized ASICs eventually overtake GPUs despite their longer development cycles? Are we underestimating the potential of other semiconductor players to disrupt this space? Share your thoughts and join the conversation below.